This is just a map showing the change in annual average temperature for Canada since 1950 to the early part of this century. And you can see that the big balls are all warming. They're all warming. And the big ones are large warm, well, 2.5 degrees C over 50 years. And the smaller ones and the X's are less warming. And you can see that the warming has been greatest in the west and the north. And that's likely to continue, although initially we had some cooling on the east coast because with more ice capping off the glaciers and a change in the ocean circulation, we had a very cold current coming down the Labrador coast, and it kept things cooler there for a longer period. But it's now warming up just as rapidly there and on Baffin Island as it is in the main part of the continent. Next one, please. And this gives you some idea of what actually has been happening in warm nights and warm days here. The number of cold nights and cold days are the blue balls are reduction in cold nights, cold days, and the warm nights and warm days over the last 54 years are shown in red on here. And you can see that the nights have been getting warmer, in fact, than the days. So the nighttime temperatures, the minimum temperatures have been going up a little more rapidly than the daytime temperatures. Next one. And this is the cautious projection of the Intergovernmental Panel on Climate Change of what we're likely to see over up until about the last decade of this century. And you can see that the average global warming is going to be about 3 degrees C now. And you can see that over most of Canada, it's going to be of the order of 4 to 6 degrees C, and especially in the far north. Next one, please. And this is a map showing the projections for rainfall or precipitation. The blue areas are the areas where precipitation is increasing in Canada's north, for example. The white areas where we see not much change over most of southern Canada. And the beige and reddish areas are where precipitation is projected to decrease again over this up to the 2090s. And it's only the colored areas are only places where we expect at least a 20% change in average rainfall. The other thing I'll come to is increases in drought conditions in the Mediterranean basin, in southern Africa, in the Caribbean. People don't realize that Barbados has the 4th least amount of water per capita of any country in the world. That's why they have a desalination plant. And the Caribbean is likely to get drier in Central America. So this is a significant worry for some parts of the world. Next one, please. I don't think we'll see this in Canada, but it illustrates the kind of thing that is likely to happen in some of the driest parts of the globe. And I would say that Canadians will feel the effects of climate change most in our water, both our water quantity and our water quality. And we'll come to the water quality in a minute. Next one, please. This is a map which shows the change over the last 50 years in the frequency of heavy rain events, intense rains. As the atmosphere warms, it holds more water vapor, and There's a very well-established theory that holds more water vapor to the tune of 7% per degree C. So you'd think that this might produce more rain everywhere, but it doesn't. It produces heavier rain when the atmosphere is set up to make rain. So what we're seeing is intense rain events occurring much more frequently, and that's projected to continue by all the climate models. And you can see that the black and the blue areas are the areas where intense rains have been observed to increase and where they will continue to increase. Now this has serious problems, makes serious problems for storm sewer systems in cities, and backups into basements, and for small-scale flash floods, and our engineering fraternity haven't caught up with it yet. So they're still designing on the old basis, in spite of good work by NRTEE to try and persuade them otherwise. Next one. Oh, one other thing. Oh, this is a graph of what we've seen in the Great Lakes Basin. Maximum 24-hour rainfall, don't worry about 7-day, is shown in green up till now, and in blue in the projected. So these heavy, short duration rainfalls, even shorter than 24 hours, but 24-hour events are where most of the data are from, are on the increase. Now this has important implications for water quality too, because heavy rain event washes stuff off city streets, causes storm sewers to overflow into sanitary sewers in older cities, and washes or causes erosion in cropland and the washing of nutrients and toxic materials into our lakes and rivers. And so we see this happening now. We see, for example, on Lake Erie, which had come back rather nicely with the phosphorus control program put in place under the Great Lakes Water Quality Agreement, we now see backsliding. It's going back to its old eutrophic form. And it's largely because of increased intensity of agriculture and increased frequency of heavy rain events. Next one. These heavy rain events are not confined to the area that was blue and black in that slide I showed you. They didn't have data from the high Arctic. But this is what happened last summer in, where was it? Pangnirtung. In Pangnirtung on Baffin Island. There's a little creek that goes through town. They had a very heavy rain event in June, just as their snow was almost disappeared. And they had this huge gully driven right through the center of town, washing out their two bridges so that it divided the town in two. People couldn't get from one side to the other, couldn't get to the stores, didn't have water on one side. They had to dump sewage right into the creek. And part of the reason that this big gully is washed away is because the permafrost is melting too, even in high Arctic in Baffin Island, but especially up in the Mackenzie Basin. Next one, please.